Okay, so the first thing I want you to do is I want you to open up your drive.
Okay. Bear with me. I don't see a way to minimize on Linux. Hold on. Oh. I actually don't know how to, oh, maybe exit full screen. Fantastic, I figured it out. Okay, so I'm on Google Drive.
All right, so once you see your Google Drive, you see that button on the top left that says New?
Mm-hmm.
With the big plus sign on it?
Yep.
If you click on that and go down to More, you should see a lot of things listed: Google Forms, Google Drawings, Google My Maps, stuff like that.
Mm-hmm.
I want you to go down to the Connect More Apps button.
All right, and what am I going to search for?
So we're going to search Colab, which is spelled C-O-L-A-B.
And I've got Collaboratory?
Yes, Collaboratory.
Cool.
So I want you to click it and install it. It will install on your Google Drive, not on your computer.
All right.
All right, so the next thing I want to do is I want you to go to we're going to go to the UCI Machine Learning Repository. And I'm going to put the link in the chat.
All right, I'm there.
Okay, so today we are going to use this amazing data set called hepatitis C virus for Egyptian patients. So if we click that link and click on this data folder, you can download that HCV EGY-data.zip.
All right.
And we're going to unzip that and put it in our Google Drive. Now, in my Google Drive, I created a folder.
Why?
Oh. Well, so that we can use the data in Python.
Okay, so we created a folder so we can use the data. Let me see. That should have unzipped too. Yep.
So I created a Python folder in my drive and just put that folder inside my Python folder.
I'm sorry.
Oh,
Hey, Charlie. Charlie, I know you're having a hard time. Can you go with mommy? Mom. Okay, so we're uploading the CSVs to Google Drive.
Right. So if you unzip the folder, you can just place that whole folder in a folder called Python in your drive. So just create a Python folder in my drive and then just plop that folder right in.
Got it. Sorry about that.
Oh, no worries. Life in quarantine times is full of unpredictabilities.
All right.
All right, so once you've done that, I want you to click that new button again. And we're gonna go down to more, and you should now have a link that says Google Collaboratory.
Ooh, and there's a dark theme, cool. All right.
All right, so once you're in Google Collaboratory, you should have something that looks kind of like this, although yours will be blank. Mine, I put some stuff up there so we can have some reference points.
Okay.
So it should be labeled untitled.ipynb. If you've used Jupyter Notebooks before, you recognize that extension. IPYNB is for Jupyter Notebooks. So you could download this from your Google Drive and run it in Python, in Anaconda, in Jupyter Notebooks, or in what's it called? Should have another program that does that. PyCharm. You could also use it in PyCharm.
Cool.
Okay. So for today, we're going to import 5 different things for now, and then we're probably going to import other things based on whatever you would like to learn.
Okay.
But for today, for right now, I have the scikit-learn metrics package, that plot Roc Curve function.
All right. And I see the linear model function.
That's actually the linear model module.
Oh, you're right. I'm sorry.
Oh, no, you're fine. It just has a bunch of stuff in it. It's got linear regression. It's got logistic regression. It's got multiple linear regression. It's got lots of things in there. And then from Google.Colab, we're going to import Drive because we're going to get Google to be connected to our Drive so we can pull on our data from our Google Drive. We're going to use pandas and NumPy, and we're going to give them aliases so we don't have to write pandas and NumPy every time.
Definitely.
Okay, so the first thing we're going to do is we're going to mount our Drive so that we can access the data. So if you use that command drive.mount and we put in /content/G drive, it will come up with this very nice little link, accounts.google.com, and with a bunch of information. If you click on that link, it'll ask you which Google account you're trying to get to. Make sure you use the same one that you're using for your Colab, and it will give you an authorization code with a little copy button next to it. You just copy it and paste it in this box that you would have gotten here and hit enter. Since it's been a while since I've run this, I'm going to rerun everything.
Okay.
No.
It's okay. I have it split screen, so I don't even see that part of the screen. You're good.
Oh, no, I just had signed into the wrong account, that's all.
Oh.
I had chosen the wrong one. I have way too many Google accounts.
I used to have that problem.
All right, so now that we've mounted our Drive, we can then use our read_CSV from pandas to pull in our CSV data, that hepatitis C data. So if you put it in a folder named Python, this is the path that it should be at. Content/G drive/my drive/HCV-EGY-data/HCV-EGY-data.CSV.
HCV data. Got it.
And if you're in the right places, I do believe it will tab complete for you. No? Okay.
Shift enter. Oh, uh-oh, file not found. Let's see. Did I type it wrong?
So my drive definitely has a space in it. It's HCV-EGY where E is capitalized. If you put the whole folder in your Python folder. Did you put the whole folder or just the?
Just the files. I think that's what I did wrong.
Okay.
So let's try that. Shift enter. And I bet it is case sensitive, isn't it?
It absolutely is.
I should know better.
Computers, unfortunately, are not super smart, no matter how much we want them to be.
And now it's happy. Hooray.
Excellent. Now, in Google Colab, to get code to run, you can do one of two things. You can hit that play button next to it, or you can do a shift enter, and it will run the cell. So now we have imported in this data that we downloaded from the UCI machine learning website. Let's check it out by using that head command. Now, if you've not used the head command before, what the head command does is gives you the first 5 rows and all of the columns. So we can see all the different possibilities in this data set. Okay. Yeah. So, first thing we might want to do is we might want to get some information about each of the different numeric columns in our data. And the way that I do that is using the .describe function. So hepc.describe. So the .describe function, if you haven't used it before, will take each of our numeric columns and give us a bunch of statistics about each of the columns so we can get information about what's happening in each column. So you can see that gender here is has 2 different values, a minimum of 1 and a maximum of 2. So they are unfortunately binarizing gender in this particular set of data. But we've also got age, which goes from 32 to 61. We've got BMI, we've got fever, and fever goes from 1 to 2, so I'm betting that they're using a binary for whether that particular person has a fever or not. Nausea, vomiting, which is another binary, it looks like.
Mm-hmm.
You can see a bunch of different binary variables here. And then we've got this WBC, RBC, HGB, which I think is hemoglobin,
Mm-hmm.
PLAT, AST1, ALT1, ALT4, lots of different possibilities. So let's go back to the machine learning website to see what they have given us. Okay, so they've given us some information about the data. So PLAT is platelets, and HGB was hemoglobin. RBC was red blood cells. Then we've got aspartate transaminase ratio, alanine transaminase ratio at 1 week and 12 weeks, alanine transaminase ratio at 4 weeks. I think they messed it up. I think the 4 weeks should have been at 4 instead of 12.
Mm-hmm.
So I think the ALT or alanine transaminase ratio at particular amounts of weeks. And then the ALT all by itself is after 24. I'm sorry, ALT after 24 is the alanine transaminase ratio at 24 weeks. And we've got an RNA base, RNA4, RNA12, end of treatment, elongation factor, So we've got a bunch of different things in this data set. And what I'd like to do is create a general linear model, a linear regression, using one of these variables as our final variable, as our target variable. So let's see, what is in the other? Let's look at the data set description. Data set description link seems to be broken. Okay. So we have this huge data set. We have a bunch of different RNA variables. I'm gonna use one of these RNA variables as our target variable here, just so we can practice doing linear regression. So RNA variables seem to have the most range. So we've got somewhere between 5 and 5,000. Huge range. Okay. So the first thing I want to do is I want to split my data into the predictors and the target. So I'm going to say X is my predictors variable. And so I'm going to take my data frame name, which was Hep C. And I'm going to pull out the columns that I want to use for my predictors. So I'm going to take age. I'm going to use gender. I'm going to say WBC, white blood cell count, and RBC, and platelets. And then I'm also going to pull out my predictor, which I'm going to use Y, and we're going to use NumPy to turn it into an array. So np.array of my Hep C, and the thing that I was going to use was one of my RNA variables. Let's try RNA EOT. Okay, so now we split our data into our X variable and our Y variable. Generally, this is best practice when you are doing any sort of machine learning modeling, especially, any sort of supervised machine learning modeling. We want to split our data into our X variables and our Y variables. And then we want to do something called splitting our data into a training set and a testing set. The first thing I'm going to do is I'm going to use those splits. Ooh, what did I do wrong? Did I do age wrong? Age is not in my index? Hold on. And X is equals 1. No. All right, easy enough. Let's try data columns. Since I didn't tell it to print, let's do that instead. Age has an extra space at the end. That's why I was having trouble.
I was wondering if it would be white space.
Yeah. X equals Hep C. What were our columns that we were using before?
WBC, RBC, and PLAT for platelets.
Excellent. All right, so we have our X variable and our Y variable. Now the next thing we want to do is we want to do something called splitting our data into a training set and testing set. Now the reason we want to do this is because when we use machine learning models, we want to make sure that our model isn't specifically overfit to a particular data set, because we'd like our models to be generalizable. If our models are generalizable, that means we can use any actions or that we have decided come out of our models, because they're not simply just for this particular set of data, these particular people. If for example, in this particular data set, we're talking about people with Hep C. To do this, we're going to import another piece from scikit-learn. sklearn, import train test. I did it wrong. Model selection, train test split.
I think there was an underscore.
Yes, you're absolutely right. Alrighty, so train test split allows us to put in our two different variables, our X variable and our Y variable, and splits our data based on a particular percentage. The rule of thumb in data science is that our training set is 70% of our data, so we're able to train our model on a high enough percentage of our data to actually get a good model. But we also are gonna keep out 30% of our data to test our model on to make sure that it is generalizable. So we're gonna need pull open train test splits documentation, because we need 4 different things as outputs. Our 2 X's and our 2 Y's. So we need X train test, Y train, and Y test. We put in our X and our Y, and test equals 0.3. And my Y is lowercase y. Okay, so what this will do is this going to take our X data and our X variable and our Y variable and split it in 30%, 70%, where each of the things in X train correspond to all the things in Y train, and each of the things in X test correspond to everything in Y test. Did I mess it up? Hold on. I did. Test size. Sorry. Test underscore size. This is what comes of doing coding on the fly. But I also really like to do coding on the fly because I like to show people that even though I've been in data science for 10 years now, I still make mistakes and I still have to look up documentation. And please do not expect yourself to be able to do this perfectly at any point in time. But the first thing you want to do is put everything into train test split. That has now given us a training set and a testing set. Now the next thing we want to do is we want to start our modeling piece. Now to do modeling in scikit-learn, there are 3 different steps. The first step is instantiating our model or initializing our model. So we have to call a model. The second step is fitting our model to our data, to our training data. And the third step is predicting on our test data set. So let me state those again. Every single model in scikit-learn works this way. So whether we have linear regression or whether we have clustering or whether we have any sort of classification, all of our data, all of our models in scikit-learn work this way. So you have to instantiate the model, you have to fit it to your data, and then you have to predict on your test data. Okay, so we'll go ahead and start by instantiating our linear regression model. I'm going to call it LR model equals what did we call it? Linear model dot linear regression. And since we imported the entirety of the linear model module, when you hit that period after linear model, you can see all the different methods in that module. One of them being linear regression, or all the different objects in that module. So if we do this, we have now instantiated a linear regression object. And that linear regression object now has a lot of different things to it. We can use our LR model. And we hit dot and we can see that list of things. The fit function is what we're going to use. And both in Colab and in Jupyter Notebooks, when you hit that dot, you're going to get that list and you can click anything on that list. I like it a lot because it keeps me from misspelling stuff. In our fit, we need our X variable, our Y variable, and whether we have sample weights. Now, we did not put together any sample weights, so I'm going to just put in our X train and our Y train here. And you can see the output from our linear regression. We've got some defaults here, including fit intercept equals true and n jobs equals none. We always want to keep fit intercept equals true unless we want to force our linear model to have an intercept of 0, but I do not recommend doing that. And then the final piece of our linear model is the dot predict function. We're going to set these predictions to a variable. So I'm going to show some of those predictions. Just print them. Big numbers. Because we were predicting our RNA at EOT, which end of No. End of treatment. Okay. So these are our predictions. One of the ways we can tell if this has done a good job is that we can calculate our accuracy scores by importing from scikit-learn. Accuracy. Spelling. And from the metrics, the accuracy score. So scikit-learn.metrics. There it is. So then we can say CC equals accuracy score of, now we need our Y true, which is our Y test, our Y predictions, which we called predictions. Hold on. All right, what happened? Our predictions should be all numeric. What do they look like? Is our test data not? So let's do Y test that is null sum. All right, so let's get back to my data frame. All right, so I'm going to check on my ATPC. See if we have any nulls. Nope, we don't have any null values. Okay. So then if our Y test was the RNA UT, that's definitely numeric. And our predictions are definitely numeric. All right, so what did we do wrong? No, we don't need any of those things. All right, let's see. Y test dot D type. Okay. And Y or predictions dot D type. Float 60. Oh, y test is just integers? Okay, that's easy enough. We can fix that. So our predictions are a float and our test is an integer. So we want float of test. And then predictions. Okay, only one. Mm-hmm. As typed. Okay. Float only works for a single variable, not an array, unfortunately. So did we do something wrong when we did them all? I'm so sorry about this. Can we use X test and Y test? We trained the model, we used X train and Y train. So it should be just fine. Weird. I have never run into this before. Weird. Okay. Well, we can always calculate the accuracy score by hand.
Would we do it as float 64 instead of float?
So I tried that and it couldn't find float 64.
Oh, darn. Okay.
Okay, let's see. Well, let's see what's in our Y test. Okay. What was in our Y train? Yeah, those look like integers as well. Okay. But the accuracy score shouldn't, it should be able to just subtract floats and integers. This is silly. It's a single array and not a matrix. Okay, yeah. All possibilities. This is bizarre. Let's see. Let's try this one more time. Change the name. Just for funsies. Well, I think we've also got it in our model. So let's check out our model. That's not the right one. That'll be our L1 norm. We can also plot these and see where we're at. So let's try that. We'll plot with matplotlib. Matplotlib. Line plot. Let's see matplot. Okay. So let's import matplotlib. .pyplot as plt. And we're going to do plt.plot of x test y test. Okay. Oh, right. Because we did we did multiple linear regression. Oops. Let's just do age for now.
The white space in age.
Well, so X-test was a matrix. I completely forgot that we don't have names of columns in there.
Oh, okay.
So 0, 1. Ah, sorry. That's, I mean, X-test should be a matrix, is it not? It does have. No, you were absolutely right. X-test is a. Okay. So we've got our age on our x-axis and our RNA on our y, and wow. So there doesn't seem to be a whole lot of a linear linear relationship between those two. Try BMI instead. Was there also white space in BMI? No, we didn't use BMI. Da, 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 da. Gender is a binary, so they're not anything there. You could try platelet count. Nope. So this is a an excellent example of how some sort of sometimes models are just really bad fits. So a linear regression model isn't a super great fit for this set of data. But now you know how to do a linear regression. Is there a particular model that you would like to learn, Mary?
Not that I can think of, no.
Okay. Well, why don't we try a classification model while we're here? All right. So there are a couple different types of, there are lots of different types of classification. Is there a particular classification model that you've been curious about?
No, I'm still pretty new, so I don't know.
Okay, no worries. Yeah. Classification. So the nice thing about scikit-learn is it's got all of this documentation online. plenty of different possible classification models. And so one of them is recognizing handwritten digits. There are lots of different, there are lots and lots of different possibilities for classification. I'm gonna say let's play with a logistic regression. Since we're already in the linear module, the linear regression module, or the linear models module in scikit-learn, we can go ahead and play with logistic regression without actually having to import a whole lot more. So let's do that. So the first thing we need to do is we need to pick a variable for our classification. So which variable would we like to turn into a label?
Now, would it be good to go with a binary one, or should we go with something that has a little bit more data?
A binary one would be wonderful because we're going to use logistic regression, and logistic regression's output is generally the probability that something is a particular class, specifically the desired class. Logistic regression assumes that you have a binary. So even if we didn't go with one that was already binary, we'd be changing one into binary.
Okay, then let's go with nausea and vomiting.
All right.
It's spelled wrong, so it's vomiting.
Vomiting. All right, let's do that. So the first thing we want to do is we're going to change our x and y variables. So we're going to go back up to x and y where we did. So our y variable is going to be our nausea/vomiting. And our x variables, what variables do we want to use? I definitely would like to use some of our fever and headache ones. You know, those are binary. Okay. But also some of the ALT and RNAs.
Sure.
And let's try age as one of them as well. I'm going to keep the white blood cell, the red blood cell, and the platelets. I'm going to add fever. And headache. And jaundice, just to be colorful. Okay, so we got white blood cell count, red blood cell count, platelets, headache, jaundice, and fever. Let's go with that for now. So I'm changing my X to those. Oh, headache, jaundice, and fever somehow must have an extra space in them. Or headache and jaundice. Can I spell them wrong? Okay, cool. And we don't have any nulls, so that's great. What we're gonna need to do next is we're gonna need to change our X, the variables in our X that are supposed to be binary to binary instead of being integer variables. So we're gonna be using this the where function in Python. So I'm gonna go ahead. Insert code cell afterwards. Okay, so we want to change the things that are supposed to be binary into binary. So I'm going to take my y variable, y equals mp dot where. And the condition is y double equals 2. I'm gonna put. And when y is equal to 2, I want it to be true. And when it's not equal to 2, I want it to be false. So that's how NP-where works. It takes a conditional and then what to do when it's true and what to do when it's false. And we'll change our variable into a very nice Boolean. So if we do this, we've got a bunch of different possibilities in y. The beginnings are lots of falses, but we know that when we used nausea, vomiting, we absolutely had ones and twos. So we're good. Okay, so we're gonna have to do the same thing for all the things in X that were supposed to be binary as well. So let's do that. So X of like equals NP dot where of equals 2. I'm going to set that to 1 and 0 instead of true and false, because I'm just going to change it into a binary, classic binary.
And do we want to do that with all of the binary things like fever and jaundice?
Yep. All right, let's see if we were able to do that. Go ahead and do. Jaundice got fixed and headache did not. Was headache binary before? Yeah, it was 1 and 2. They got changed to all zeros. Oh, it's because I ran it more than once. That's my
Oh, yeah.
All right, hold on. Okay, cool. Headache and jaundice got fixed. Fever still has to get fixed. So I'm going to do that here. Does not have a space in it. Okay, cool. And now we're going to take our X and our Y, and we're going to split it into two different pieces, our training and our testing sets. And then instead of using linear regression, we're going to initialize a different model, LG model, or logistic regression, or that's what I'm using. And you can see logistic regression is right there. For logistic regression, we're just going to initiate the model. LG model.fit, we need our X train and our Y train. Exactly the same as how we did with linear regression. But instead of .predict, we're going to use .predict proba. Or I'm sorry. And instead of getting values from our linear regression, we're going to use predict to get our classifications. So when we print predict now, okay, did we forget to change Y? No? Y is true and false. Why is our prediction? Oh, we forgot to change. No, we changed X test so everything was ones and zeros, right?
For Y, we did Boolean.
Right, so we should have gotten trues and falses as our predictions, not ones and zeros. Okay, hold on. Let's try this one more time. Yeah, I forgot to run the section on Y again after I reran Y. So now we get trues and falses. And we can use the accuracy score now because the accuracy score, I forgot that this particular accuracy score is specifically for classifications. So we can do accuracy score of Y test and the predictions. And we're going to print that. We have an accuracy score of 54%.
That's so bizarre. I got 49%.
Okay, so the reason that you would do that would happen is that we used a randomized split using train test split. So you have a slightly different training set than I do.
Okay.
So it would make sense that you would have a slightly different accuracy score.
Okay, cool.
But we have now officially done a machine learning model and printed our accuracy score.
Yay.
Now, the other way we can, so this is one of the ways we can decide whether our model is doing a good job or not by using the accuracy score. But also, we can use something called the Roc Curve. So that's what I imported before. That's like plotting of the Roc Curve. So let's go ahead and do that. Roc Curve. And we need our estimator. For us, it's LG model. Our X, and we need X test, and our Y test, and I believe that's everything we need.
All right.
Now, what our Roc curve, the receiver operating characteristic curve, tells us is it looks at our true positive rate versus our false positive rate. And what we really want for a Roc curve is the area under our curve to be as close to 1 as possible. Now, this logistic regression gave us an area under the curve of 0.54. So 0.54 is really, really close to basically having a coin flip.
Mm-hmm.
So our model is not much better than a coin flip right now. What we really want is we want to maximize our true positive rate while minimizing our false positive rate. And that would give us a very large area under our curve.
How would we do that?
So we might pick better variables.
Okay.
We might use a different model because logistic regression might not be the right model for us. We might use something like a gradient boosted tree or a random forest or a neural network. These are all a little bit more complicated models than logistic regression. Mary, have you done logistic regression before?
No, I haven't.
Okay. So logistic regression is a little different than linear regression in that it is looking at the probability that something is classified as a 1 in our model here.
Mm-hmm.
And since we set our y variables to be true or false, right? Generally, the way Python interprets a true is as a 1 and a false as a 0.
Mm-hmm.
So logistic regression is looking for looking to create coefficients for our model that give us the right probabilities that our y variable is equal to 1. So when we train our model with the data that we gave it our x data and we gave it our y data, which was trues and falses. We were looking for the coefficients that made the probabilities that we got out of that model close to 1 when we had 1s in our y variable and close to 0 when we had 0s in our y variable. Does that make sense?
Mm-hmm.
So when we gave it our test set, it now says, yeah, your accuracy is about 54%. So I think we have chosen bad variables. But either way, you now know how to take a data set and fix the binary variables to be binary, split it into your x variables and y variables, instantiate a classification model like logistic regression, fit it to your training set, and calculate the accuracy score on your test set, as well as plot your Roc curve.
Awesome.
So you could feasibly just import a different classification model. Like, for example, let's do a decision tree. So instead of that sklearn import, so from sklearn import tree dot. All right, where's my decision trees? Decision tree classifier. Tree.decision tree classifier. Okay. So we can import tree.decision tree classifier. I'm sorry. Tree needs to be next to the scikit-learn. From scikit-learn tree import decision tree classifier. And then we could simply, we've already done all of this, we could simply replace this LG model with our decision tree. So I'm just going to put DT model underneath it. Decision tree classifier. So that's just going to initialize our decision tree model. We're going to use the fit just like we did for the logistic regression. Do a prediction on X test, just like we did before. And then where did I put my accuracy score? And we can say act2 equals accuracy for y test pred2, and pred2 is from our decision tree. And then we want to print it. Our decision tree doesn't do much better. But that's a whole nother model. So like you've done a whole nother classification model, what, in like 5 minutes? And we can do the Roc curve exactly the same. For a decision tree classifier. Now, when creating these models, one of the things you might want to look at is you might want to have more information about your data. We were predicting nausea with a bunch of information in this data set. However, if we look at our data set, we have a whole nother discretion CSV where they have told us what the different values are here. And when we look at the website that we got it from, all patients who underwent treatment for hepatitis C. So we might want to use a different variable as our target variable instead of nausea, vomiting.
That makes sense.
Like, I don't know, we may want to split up our RNA end of treatment into some different classifications and classify our database that way. But that is all based on knowing your data. You have now all of the capabilities to create a classification model or a regression model and check out how you did.
Cool. Thank you.
Yeah, no worries. And you didn't have to download any software.
Hooray. Yeah, that's really neat that I can just run it in Drive.
Yeah, no, for sure. I'm really excited about that. I am trying to figure out how best to explain using Colab for R as well, because you can use Colab for R currently.
Mhm.
So I'm working on a class for that. Hopefully, I'll be able to present that next week.
That's exciting.
Well, do you have any questions as of right now?
For downloading data, is UCI where we want to go, or are there any other sources like Kaggle? I know is one.
Oh, absolutely. So we've got Kaggle, we've got Data World, we've got UCI, we've got there's a whole article about 5 big places to go. So there's UCI, there's Kaggle. Scikit-learn also has a ton of different data sets that you can download within
Okay.
Scikit-learn. And if you do this from scikit-learn datasets, import whatever data set you want, you're doing that right inside your Python notebook.
Okay.
So you don't even have to download it and put it in your drive. This will just happen all in the notebook.
Oh, that's fantastic.
But I wanted you to be able to put it into your notebook from your drive, just in case you have data that you wanted to put in there.
Okay.
Which is why I did it the way that I did it today, instead of using the scikit-learn built-in data sets. But then we've also got drivendata.org, and 538 has a bunch on their GitHub. And with Colab, you can just connect it directly to GitHub and pull it in that way. So when we have our path in our read_CSV function, remember so this is basically our file path to our to where we had put it on our drive, right?
Yeah.
You could also just put a web address in there.
Okay.
And it will just pull in the CSV from the web address.
Okay, great.
It's pretty cool.
Now, saying that we finish a project and we want to save it for a portfolio, would it be good to just copy all of that data over to a GitHub repository, or?
So you can do that, especially if you want it to be available for other people. But you could also just save it straight to your drive. So once you've done a bunch of stuff to your data frame, you can use your data frame name .to_CSV and like put in the file name, and we'll save it to your drive.
Okay.
As a CSV. So that then you can have it to give wherever. You can email it, you can
Awesome.
send it to people, you can give people links to share.
Cool.
But if you want some information on how to do some really awesome plotting in Python, I did a whole thing on matplotlib a couple of weeks ago, and that's on YouTube. And all of that code that I've taught already will work in these Jupyter notebooks on Drive.
Okay. Where do I find you on YouTube? Do I search Dr. Red, or?
If you just search Veronica Red, I'm the only one that has a channel named that.
Oh, did I spell you wrong? Is it with a K?
No.
Oh, there you are. Right underneath Veronica with a K.
Yeah.
Cool. Thank you.
Excellent. All right. Well, Leland, do you have any questions? I know you joined us a little late.
Yeah, most of the only questions I have are like stupidly specific, so I'll just message about you offline about that.
Okay. Well, I mean, you and Mary are the only ones in class right now, so like, if you wanted to ask stupid specific questions, you were welcome to.
Okay, so I actually, for my job, set up an Introduction to Python Colab notebook. So it's linking from a Canvas, from Learning Management System over to the notebook.
Right.
So the couple things that I'm trying to do, first, importing, so for the one that I'm using, they're using Pandas and MATLAB to do some basic visualization stuff.
You mean Matplotlib?
Yeah, MATLAB, excuse me, not MATLAB, yeah.
Okay, cool.
So one of the things that I want to have them do is import the different data, not data sets, the different portions themselves, like pandas, like scikit.
Mm-hmm.
And I'm trying to decide whether or not is it worth to put those download instructions into the Colab, just in the beginning as a note, you'll be using these, here's how to download them, or is it better to split it up because, again, it's intro? Should it be better to just split it up into a, here's the basic syntax, here's the basic stuff, here's the more advanced fun stuff?
Mm. So generally when I teach Python, I always teach like a basic class at the beginning, which has how to import packages and the different data types.
Okay.
Especially for people who haven't coded in Python ever.
So basically split it up so they can, the stuff that anybody who's a little more advanced can just skip over it.
Yeah.
That's fair.
But I would say in Colab, you don't have to download anything. The nice thing about Google Colab is it's got access to every single one of the packages. So all you have to do is import them.
Oh, okay.
When you're using like Python on your computer, you generally have to install packages first before you can import them.
Sure.
But in Colab, you don't, because Google has access to all of these things.
Oh, very cool. Okay.
Which is really nice. And it doesn't matter what your operating system is if you're using Colab, because you're using it from Chrome or from Google Drive. And so you're using Google's operating system, not yours.
Ooh, that means use their bandwidth, use their power, not mine.
Right.
But yeah. Great class, by the way.
Thank you. Well, I'm going to go ahead and stop recording then. And anyone who wants to find any of the other classes that I have, look up Veronica Red on YouTube. All of my classes should be there. This one will be up there this evening as soon as the recording is done. And happy Beltane, everyone.